All right, so let's talk real quick about testing methods. It's called unit testing. One of the biggest frameworks that we use for Java for unit testing is JUnit. JUnit is built into Eclipse. It is it's a package like we talked about in whenever we import like the scanner and stuff, we give the project the exact spot where the library is with all the supporting files and methods that we need to use the scanner, so we don't have to recreate them all the time. Same idea with JUnit, excuse me, except this time we're going to put something on what's called the build path. And the build path for the JUnit test case is easy to implement and integrate in Eclipse. It already has the library downloaded. All we have to do is add it to the line to tell that we're going to create it, or that we're going to use it, excuse me. So I want to walk through really quick what this looks like in Eclipse, and then we will pop over to Eclipse and you can do it with me. So for the time being, just watch, and then we will flip over and I'll do it real time with you in Eclipse so that you can see it in action and have an example whenever you leave class today. So whenever we create start using unit testing, we end up with two Java files. So we end up with one that has our method inside of it, and then we end up with another that has our unit tests inside of it. So our unit test will actually run our methods inside of our class, and it will capture those results and compare them. And if they match what we are expecting, then the unit testing will pass. If they don't match what we were expecting, then the unit test fails. And there could be multiple reasons why it fails. So we do end up with multiple classes. Usually the classes will be like, week 3 examples, and then it will be week 3 example tests. That's the convention that Eclipse and actually that JUnit has come up with. So in Eclipse, once we have our methods created, usually, sometimes you will create your test and then create your methods. That's called red-green testing, and we'll talk about that more next week. But usually you will have your methods already created and then implement your test with it. So to get to those, you'll just go to File, New, and down to JUnit Test Case. If for some reason that's not showing up as the default, you'll go under Other, and we'll find it listed underneath there. But once you use it once, then it will continue to show up under your file New. Once we click that, it will ask us to name our test. Where do we want to put it? This kind of looks like whenever we create a new class. We've got our new, we have 3 versions of JUnit libraries in our Java packages. We have our Jupyter, that's also sometimes called JUnit 5, and we have JUnit 4 and 3, obviously. This is where they kind of went off the rails by calling JUnit 5, instead of calling it 5, they called it Jupyter. And interestingly, the nerd in me was like, why do that? Why change it? Well, Eclipse started naming their releases after, planets and just kind of futuristic names. Like they had some that were like Neon and Mars. And anyway, so that started happening with Eclipse. So JUnit switched over to naming theirs after planets. And then after that happened, Eclipse is like, yeah, we can't maintain this naming convention. So they went back to naming it as you see it now, which is like 2020-09, which stands for the year and the month of the release. So they kind of got bit by trying to follow what somebody else was doing. I guess that's another proof to, be your own person, be your own company. Don't go chasing after somebody else's. But anyway, I digress. We want to make sure that our name matches our class, and JUnit will do this for us by default. We would have to change it. There are some method stubs down here too. We can have things work before we set up the class or before we set up the test to be run. So further, once we get to working with classes and objects, we will use that setup to actually create our object, and then we'll be able to use that same object, to test throughout our whole program, which is really cool. Same thing with teardown. Let's say that we were pulling some data from a database, and maybe we didn't actually want that data to be adjusted. At teardown, we could do a revert so that that data inside of that database never got changed. So for now, we're not going to worry about those, but I did want you to know that those are there, and there's a lot more documentation, and we will get to using those in a little bit. After we click next, next in Eclipse, the next box that pops up is going to say JUnit 5. See how they switched it to 5 instead of Jupyter? Tricky little They think they're tricky. JUnit 5 is not on the build path. Do you want to add it? And the answer is yes, we want to add it. So adding it to the build path brings it into our project so that we can continue using those components, those methods with it, and it's all contained right inside of our project. When we get to Java 2, instead of bringing those libraries in and bundling them with our project, what we're going to do is we're going to put in a pom.xml. It's a Maven file, and I'm sure you've heard of XML files, that will reference out to a local, or excuse me, a repository out there on the internet. So we don't have to keep bringing all these packages into, and these libraries into our project. So if you think of it like a hamburger, you can see my hamburger hands down here. Right now, our projects are probably just those little itty bitty hamburgers, you know, on really thin buns. Think of them, I don't eat hamburgers really. You know, like think of your cheap hamburger here. And every time that we add stuff to the build path, our hamburger gets a little bit bigger and bigger and bigger. And eventually, whenever we get into Java 2, and we're dealing with these large projects with access to databases and publishing on the web and sending them out to GitHub and doing automatic builds and everything, our projects will get this big. Well, we can't eat a hamburger this big. We need our projects down to a small manageable size. And one way that we can do that is by using our Maven or our Maven, our POM files to manage these libraries so that they are not part of our big hamburger. They're not part of our package. Instead, our package just stays nice and small and it's just our code. It's pretty cool. So for now, we're going to add this to the build path. Just know whenever you get to Java 2 next fall that we're not going to add it to the build path. We're going to put it into the Maven file so that we can access it wherever we are. Now, the first thing that happened, or after that, is added to the build path, then our class gets created. And it looks a little bit like this. You'll notice that these imports are up here. You can see that they are referencing some assertions. Well, I don't know what those are. But look, I'm going to be able to get pieces of information from there, so it must have been important. They must have included it for a reason. I could see my class, and then on line 7 here, I have an @test annotation. Anything that begins with that @ in Java, followed by a capital letter, that's called an annotation. We use them a lot. They are a way to give our code meaning. So whenever we get to making connections to databases, we will put in an entity, an @entity annotation. And this will make it so that Java knows that this object, this class that I've made, it represents a table or a piece of information inside of a database somewhere. And with that entity annotation comes a whole bunch more annotations too. Think of, if you've taken any database, you know that you have to have an ID field that comes with it. You've got all your different data types, all your different fields, tons of information that goes into creating that table. And you'll be able to spell it out inside of your Java object so that whenever a cat is passed in, it knows to take that cat and save it to this cat table inside of our database. So this is your first experience with an annotation, very powerful. Line 8 is our return type. You can see void there, and we have the method name test. So inside of these tests, next week we will create multiple tests for each method that we create. So we'll have more than one method inside of a class, and we'll create different tests. For now, we're just going to use the default as we get our feet wet this week. So this should look somewhat familiar from what we talked earlier. The difference is you'll notice there's no public here, right? No public. Usually we're used to seeing public there. Well, that's because if it doesn't have a access modifier there, it is only going to be accessible in the package that it's in. Well, that's perfect for tests because we don't want, some other program grabbing all of our tests and using those. So the public's not as important there. We don't have the keyword static. The static stays inside of the class with the main method. There are exceptions to that rule, but we don't need it here as well. So method here, it has a return type of void. It's not going to return anything. And then a method name of test, and it doesn't take any parameters into it. Now this right here, line 9, this is actually our first test here. It's called fail not yet implemented. So this method is going to fail with an error that says not yet implemented. So it's not anything tricky, not meant to trick you or anything like that. It's just there because what we don't want to happen is to create a test and then we run it and things automatically pass. No, we want to make sure that the default is a fail so that whenever we run it, and if it passes, great, that assumes that we're testing our method and that it's success. So inside, the method is called test. Line 8, this test this is called a test method. Inside of this test method is another method called, is a method call, like we're calling this method, fail. So this would be like on our create a new user example, our method is called create new user, but maybe one of the methods that we call inside of that create new user is hash password. And so this is another method call inside of it. I will show you where that's going to be output to right now. So whenever you run this using your green play button up at the top, a tab is going to pop open, and a JUnit tab, and it will say right down here, can you see it? Let me see if I can try to point to it. Right there is our error right there. Here we go. So our JUnit pops open. A green bar means that our test fails. No surprise there. We can see which test files that we're running, and then once that and here's where the method is. So if I had more than one method call or asserts checks in there, they would all display down here. But you can see right here, this is, I have a failed error, and there's my message that I output, not yet implemented. And I didn't output that actually, that's the default by JUnit. But you can see right away, look, it failed on line 9, that matches up to what we have over here. And so we'll be able to track down exactly where it fails. So it doesn't appear in the console, it appears in the JUnit tab. And once something fails, we'll see that red bar along here. So as we add tests to check our methods, they're going to go inside of this line in between lines 8 and 10. We're going to add our methods in there to check our methods. Now the methods that we use to check the results from a method that we've created are called assert methods. So an assert method, there are several of them, and I have a document inside of Blackboard that has them listed in there so that you can see an example. I think there's a whole page of them in there, but one of the ones that we're going to use today is the asserts equals, and I'm also going to show you the assert true and the assert false. So assert methods are what we use to check, and there's essentially two components to an asserts method. One is the expected value. That's what comes first. So this is what we're expecting to get whenever we call the method. And then 2 is the actual method. So this is the actual method call with the appropriate parameters passed into it. So we have assert equals. So this is going to check that what we get as the actual value matches what's inside of the expected value. And if that passes, we're going to get green inside of our box here, and if it doesn't pass, we're going to get red. So that's why sometimes you'll hear this called red-green testing. So let's look at our example from this week. We have a method in there called total that takes an integer, adds 10 to it, and then returns that value. So if we want to test that method, and remember, we're going to do this together in just a minute, so you don't have to be frantically typing right now. So if I wanted to test this method, I could see that if I passed in 10 as my parameter, I should receive 20 back as my expected result. So here's my method call. I'm referencing it by calling the name of the class, the name of the method, and then any parameters that I need to pass in. That's going to be after my second parameter into this asserts equal method. My first one is going to be the expected value, or what I expect to get out from or return from doing this method call. So if I create this asserts equals method, pass in 20, and then I do the actual method call, that should be good because remember we're taking just the value that's passed in, we add 10 to it. We should end up with a green line saying that this passes unit testing, which is awesome. There are several, like I said, several other methods. There's asserts equals. There's actually 2 asserts equals, which if you haven't learned about method overloading yet, you will this week. So this will make more sense. This is the same method, but we have a different number of parameters passed in. That's called method overloading. Assert true, assert false, and then there's, of course, there's assert not equals as well. Obviously, assert not true would just be assert false, and assert not false would be assert true. So with our assert trues and assert falses, these are going to be a return type of a Boolean coming back from that method that we're going to check it with. Okay, let's flip over to my Eclipse. Okay, so in our week 3, we had a method that we called total. If you don't have this in here, you can really quick, remember file new, create a class called week 3 examples, insert the public static void main, and then add in this. So this method called total takes in a number, adds 10 to it, and just returns that new value. Don't worry if you have this or don't have this method. We're not going to use it today. I'm going to walk through putting in JUnit or creating a new JUnit class, and then putting it on the build path. All right, so I've got my week 3 open. I'm going to go to File, New, down to JUnit test case. Go ahead and follow along with me. The great thing is that a lot of this is going to be automatically filled in for us. So take a look up here. New JUnit Jupyter test case. And actually, before I continue on, was anybody missing it in this list here? Does anybody need me to show you how to get it into this list? So File, New, and they don't see JUnit test case, you can go to Other. And then I'm going to find it. There it is, under Java, and then down to JUnit, in case those are not displaying for you on the recording. In Java 2, we'll get into the test suites, which are kind of cool. Spoiler alert, you can create a lot of tests, and then you can create a test suite, and it will run all of your test cases at once, instead of you having to run them all individually. So you create a big project and add them all into the test suite. You run the test suite, it runs all of your test cases across all of your different classes. It's great. Okay, so new JUnit Jupyter test, week 3 examples. That is the name of our class, adds the word test at the end. We're going to leave these items blank and then click Finish. Here's that error that should pop. It's not error. It's not error. Shouldn't have called it an error. Giving it a bad rap. It's not a bad rap. Here's Eclipse trying to help us to make sure that we get JUnit 5 put on the build path. So all we have to do is click OK. And once it does that, if you peek over here inside of your Package Explorer, check this out. You'll see your JUnit 5 down there, as well as your Java 1.8, which is pretty sweet. So all of these different packages or libraries came in with that import statement. Pretty cool. Now, let's go ahead and run this so that you can get that JUnit tab to pop up. So to run these tests, just go up there to your green Run button, and it should run. Mine's thinking. There it is. You can move this around. So, you can move it down here next to the console. You can move it over here in another window. I think it's kind of annoying being right over the Package Explorer personally. I like to move it over to the side because I use this whenever I grade and I need to be able to see all of my files, plus my code, plus my JUnit, and then I have my console down here at the bottom. So that's where I like to move it. I just grabbed on the tab and clicked it and can drag it around wherever you want it to go. So I'm going to keep mine over here. Now, did we all get that red bar? Ooh, I bet we did. And a lot of people, they see that red bar and they immediately panic. And it's not a panic situation. This is actually good. We can learn a lot by failing, right? Failing first. So this just says can I open that tab again? All we did was run it, and that tab opened automatically. So the green Run button with the test file up, and that should have opened for you automatically. Actually, and here's a good tip, if it didn't, or if you close it or something like that, under Window, down to Show View, you can add back any of those screens that you need, or any of those tabs. There's the console in case you accidentally close it, the Package Explorer. Under Other is where you'll be able to find that JUnit one. All right, so we can tell down here, here's our failure trace, which sounds a lot more negative than what it should probably, but this is your clue right here where your error happened or where your failure happened. So one of the cool things, or maybe it's not cool, you may change your mind on this, but as you're working through test, the test will run in order. So, line 14, line 15, line 16, line 17. But once a line fails, so in this case, line 14 fails, nothing else will be tested after that failure. So if you're creating your test and you put in your asserts and they're failing, you may want to go back and look at your code, because it could be that you have forgotten to remove this failure assertion or this fail method. Believe it or not, it happens all the time. So let's write a test to test our method. So I'm going to take out that failure, line 14, make sure that I'm in between my curly brackets, and I'm going to use my assert equals. And if you remember my example earlier, this assert equals takes in two parameters. It takes in the expected value plus the actual value. So we'll run expected 20, and we'll pass in 10 as the parameter. I call this by naming, or by I access this by calling the name of my class, examples, week 3 examples, dot, and look, whenever I typed in my dot, it tried to predict which method I was going to test. How awesome is that? Check out this help that Eclipse has given me. Here's the name of my method. You can see here's my main method, and look, right here's my return type, void. Return best streaming service, here it is again. My return type, string. Total, here's my values, or excuse me, my parameters going into it, and here's my return type, integer. How cool is that? So you don't, like I said, you don't have to remember everything that your method does. You can let Eclipse help you. Thank you, Eclipse. Okay, so let's put in our total, and then in order to get that 20, I have to pass 10 inside of it. Now, if I run this, there it is, my green bar. So there is my passing method. Awesome. Now let's test it again. I know this is a really easy method. It just adds 2 or adds 10 to it. So let's do 30, and we'll do our week 3 examples. Spelling matters. We'll pass in 20, semicolon at the end. There we go. And if you click this down arrow, you can see this is the test method that it's running. So that matches up with this over here and tells us what all we're running. If I have this as private, if I have my total method as private, this means that no place else can see it besides inside of this class. So whenever I go to try to access this outside of this class, check this out. Now I've got that error up here inside of my test that says it's not visible. So yeah, if you're getting something but it not being visible, definitely go check those access modifiers because they do have to be public in order for us to see them outside of our class. This reminds me of another important thing too. Make sure that you're hitting save. So, if you make changes to your week 3 examples, like let's say that I turn this all into one line, we want to make sure that we hit save on it too. I'll put it all in one line just for the fun of it. There we go. So we want to make sure that we make the changes that we save or the changes that we make in week 3 are saved before we try to run the test. If you don't have it automatically saved whenever you run, that'll save you some time. But I want to give you one more example before we sign off today, and that is using the asserts true and the asserts false. Cool, sounds great. Okay, so inside of this week 3 example, maybe kind of mouse up just a little bit or scoot it up just a little bit, I'm going to create another method. And this method is going to accept a number, and it's going to return true if it's even or false if it's odd. So I'm going to have my public static. It's going to return a true if it's even, false if it's not. So what is my return type for my method going to be? And what would be a good name for this method? Is user number even? Oop, even. And we'll take in an integer and we'll call it num to check because this will be the value that we're going to check. There we go. Okay, so right now it's complaining because it's saying, hey, you need to have a return statement because you told me that my return type is going to be a Boolean. All right, settle down, Eclipse. We'll get to you. Don't you worry. Here's a little preview for next week. We'll be doing some if statements. So if our num to check modulus 2 means divided by 2 and it has a remainder of 1, then that means that our value is false. That means it's odd, right? So let me double check my logic. If the number to check with the modulus 2 is equal to 1, that means that it's going to be like 5 divided by 2, or excuse me, 5 divided by 2 is going to be 2. That leaves 1 left over. Yes, that's odd. So that's going to return false. Else means it's going to return 0. I don't really need to do a check because it's either going to be 1 or 2. Else we're going to return true. Come on, spelling counts. There we go. So here's my simple method. So now let's create another test. Cool? All right. So we are outside. Give you just almost there. There we go. Okay. So we are outside of this test, the first test that we created, but we're still inside of our week 3 examples test. We're going to start by adding the annotation at test. It's going to be a return type of void. We're going to call this test, and we're going to say the name of the method that we're going to test is user number even, and no parameters go into the test. There we go. So this is my skeleton for where I'm going to put all my assert equals or my tests inside of there. Now this method, because it returns a Boolean, this means that we get to use our assert true or assert false. And if our logic is correct, fingers crossed, let's start with our assert true. And in this one, we don't need to put in a 2 parameters going into the assert true, because we're just going to call the actual, because the return that it should be is right here inside of the method name. So let's make our method call week 3 examples dot, thank you Eclipse for not making me type all this out again. Here is our is user number even, and I need to put in a number to check. I'm expecting a true, so we'll put in 4. And then I'll go run this, and fingers crossed, awesome. I got a green bar. I can see that my test passes, the first one that I wrote, and then I can see that my test is user number even, it passes as well. So let's look at this one, let's do another one here. Let's do an assert false. And as you're probably guessing, whenever you go to write some of these, you're going to be able to do some copying and pasting. So in this example, we are expecting to receive a false back from this method, meaning that it's not even. Fingers crossed. Yeah, there's our green bar. Everything passes. Now, if I messed it up, oops, I wrote true in here, I would get a failure, and I would be able to tell which one failed. So if you look at this, this one passes. This test method with this assert equals, this all passes. But I can see the error because of this blue X is inside of my test username. Test is user even. And if I look over here a little bit further, expected true, but was false. So that's where my clue, and then it happened on my test in line 21. Which is this one right here, which is true because that's the one I messed up so you could see it's false. Now, just because you receive a false doesn't mean that your test is wrong. It could be that your method is wrong. It could be the issue is with your code, and you may need to go back in there and fix your code. So now if I run this, I should get my green bar again. Oh, I do have one more example I want to show you. I don't have a good method for this, but it has to do with this assert equals. Actually, we talk about this in the Blackboard stuff, but I wanted to give you one example. And you don't need to type this out because it's not going to make much sense based on what we have. And actually, I'll probably complain because, oops, 20.5, because the data types don't match up. Now we have another method with our asserts equals that has 3 parameters. The ones with 3 parameters are our actual, or excuse me, our expected. Here's our actual. And then our third parameter is what's called the delta. So the delta gives us a little wiggle room on our values that we return back. So your delta could be, as long as the expected value is within 1/10 of what we receive, or 1/100th, excuse me, of what we receive, we're good to go. So this kind of gives you a margin of error, which is really helpful whenever you're dealing with things that have tax or shipping costs or something like that associated with it. So I'm not going to get into it deep here. Blackboard stuff does have an example where you do have a spot where you can put in a little bit of a margin of error in order to get it to pass. And I think if I run this, yeah, that's going to fail. Expected 30, but was 30.5, it was 30. So this is a little, kind of a cool little thing so that you don't have to be exact to the decimal point every time. Because as you've seen in your example, sometimes your rounding can be like 0.4495 and sometimes it can be 0.45. So it just depends on your different virtual machines, what your rounding comes to.